Hello everyone. Today in this video we will discuss about the wedge friction. So first of all, what is meant by a wedge? Wedge is usually of a triangular or a trapezoidal in the cross section and it is used for slight adjustments in the position of a body. That is for tightening the fits or keys for the shafts. Now we will see the free body diagrams for the wedge friction. Now everyone observe this diagram. Here one body is there and one wedge is there. So before getting into the free body diagrams, once again we will revise what is meant by a free body diagram. Free body diagram is a diagram which consists of only reaction forces. That too you will get the reaction forces by eliminating the supports. So to draw the free body diagrams, we should calculate how many supports are acting on that particular body. So supports are very important. So first of all we will see the supports for the body individually and for the wedge individually, and we will see how many reactions are coming from that supports. So here everyone observe the body diagram. Here how many supports are there for the body? Here one support is there, and here when you are drawing the free body diagram for the body individually, wedge is also considered as one of the supports only. So wedge is one more support. So for the body, here one support and here one more support, that is wedge support. So from these two supports you will get the two reaction forces. So let us consider whatever the reaction force that is coming from this support is considered as R1, and from the wedge support reaction is considered as R2. So for the body reactions are R1 and R2. Now everyone observe the wedge body. Now how many supports are there for the wedge? Here one support is there, and when you are drawing the free body diagram for the wedge individually, body is also considered as one of the supports only. So body is the second support for the wedge. So for the wedge, here one support and here one more support, that is nothing but body support. So from these two supports for the wedge, you will get the two reaction forces. So whatever the reaction coming from this support is considered as R3, and from the body support reaction is considered as R2. So for the wedge reactions are R2 and R3. Once again, for the body, here one support, here one support. So from these two supports you are getting R1 and R2 reaction forces. Next for the wedge, here one support, here one support. From these two supports you are getting the two reaction forces R2 and R3. So completely four reaction forces from all the supports for the body and for the wedge, which are coming from the free body diagram. And one more thing, body acting on the wedge and wedge acting on the body, that reaction will be same only. So that reaction is coming from this part. So that reaction is considered as R2. So R2 magnitude will be same, as both are acting in the opposite direction and both are acting with the same magnitudes, with the same impact. So R2 magnitude will be same, and they both will act in the opposite direction. So it is considered as R2 for the body and again R2 for the wedge. So here you need to calculate R1, R2, R3 magnitude values. And here one more thing, here W is nothing but a weight of this body which is acting in the downward direction. And here P is nothing but external force which is acting on this wedge. Next here alpha is nothing but angle of the inclination of this wedge which is in the triangular shape. So generally in the problems they will ask to calculate R1, R2, R3 and P magnitude values. Now how you will calculate that values? Once if you draw the free body diagrams for the wedge and for the body individually, then from that free body diagrams easily you can draw the rectangular components force diagram. And we all know that every body will be in the equilibrium condition. So from that rectangular components force diagram, if you apply the equilibrium conditions like sigma h is equal to 0 and sigma v is equal to 0, you will get the equations. From that equations, from the basic mathematical calculations, you can calculate the R1, R2, R3 and P values very easily. So first diagram is free body diagram for any problem when you are getting a wedge friction problem. So from that free body diagram, next rectangular components force diagram. From that rectangular components force diagram, apply the equilibrium condition sigma h is equal to 0, sigma v is equal to 0. From that equilibrium conditions you will get the equations. From that equations you will get the R1, R2, R3, P values. Now before getting into the free body diagrams of the wedge friction topic, I want to tell some important differences for the smooth body free body diagram and rough body free body diagram. everyone observe these two diagrams. Here we are taking the same body. That body is in the contact with the smooth surface here, but the same body is in the contact with the rough surface here. Now what is the difference means, here we are considering the smooth surfaces. When you are considering the smooth surfaces, you will not find any resisting frictional force. So when there is no friction means you will not get any angle of the friction in the free body diagram. Now everyone observe the free body diagram for this smooth surface body. Here one support is there. We need to eliminate that support. So that support is acting on this body in the upward direction, exactly to the perpendicular direction to the surface of the contact of the two bodies. So you will get the reaction in the upward direction, in the perpendicular direction to the surface of the contact here. So this is the free body diagram when you are getting the smooth surface. Suppose for example, instead of the smooth surface, if you are getting a rough surface body, when you are getting a rough surface, then you will get a frictional resisting force. So when frictional resisting force is there, for that particular body, you will have some angle of the friction also. So by eliminating this support, you will get one reaction force in the free body diagram. So in that free body diagram, you will get one reaction force from that elimination of that support in some direction with some angle of the friction to the perpendicular of the surface of the contact. So here you are getting one reaction force by eliminating this support in some direction with some angle of the friction. Angle of friction is nothing but phi. So R with some angle of friction to the perpendicular of the surface of the contact. Here this is the surface of the contact. Here this is the surface of the contact for the smooth surface and for the rough surface. Here smooth surface is there. So you will get the direct reaction force in the perpendicular direction to the surface of the contact. Here you will get the reaction force with some angle of the friction to the perpendicular of the surface of the contact. Difference is, here smooth surface you will not get the angle of the friction. Here rough surface is there, some resisting frictional force will be there. So from that frictional force you will get some angle of the friction. So you will get the reactions with some angle of the friction to the perpendicular of the surface of the contact. This is the only difference you will get in the free body diagrams when you consider the smooth surfaces and when you consider the rough surface. Now we are drawing the free body diagrams for the wedge friction. Wedge friction is nothing but an application of the friction only. Obviously you will get the frictional resisting force. So from that frictional resisting force you will get some angle of the friction. So whatever the reaction forces here R1, R2, R2, R3 which are coming for this body and for the wedge, you will get with some angle of the friction to the perpendiculars of that surface of the contact only. Now we will see the free body diagram for the body and for the wedge individually. First of all we will draw the free body diagram for the body first of all only. Now here body shape is in this way. So once again draw the body shape. Now before getting the reaction forces, first produce the perpendiculars to the surface of the contact from the supports. Here for the body, here one support is there, here one support is there. So here you will get one surface of the contact, here you will get one more surface of the contact. So to the two surface of the contacts, draw one perpendiculars. Draw one perpendicular to the first surface of the contact. Draw one more perpendicular to the second surface of the contact. Why? Because to that perpendiculars only with some angle of the friction only you will get the reaction forces. So before getting into the reaction forces procedure, first of all we need to draw the perpendicular lines to the surface of the contact. So here one surface of the contact is there, here one more surface of the contact is there. So for the two surface of the contacts you draw two perpendicular lines. Next, now here R1 is there. So for R1 again separate procedure is there. Why we need to opt separate procedure means, here observe the support for this body. Here support is completely towards the left side of the body. Left side means we can consider the second quadrant or third quadrant. So we are not exactly sure from that two quadrants by eliminating that support into which quadrant the reaction will come. So we need to opt again some separate extra procedure. Now we will see that extra procedure for R1 reaction quadrant. So here draw one small x-axis and one small y-axis. Now as we are getting the quadrant for the R1 reaction for the body, we should see the motion of the body. Now observe the main diagram. Here when external P force is acting on the wedge and body and wedge are in the contact position, when this P is applied on this wedge, body will move in the upward direction. So motion of the body is exactly in the upward direction. Upward direction means it may be in the first quadrant or second quadrant. So motion of the body is in the upward direction. Upward direction is considered as first quadrant or second quadrant. And we know that friction and motion always opposes to each other. So as a motion is in the upward direction, you will get the friction in the downward direction. Downward direction is nothing but it may be in the third quadrant or it may be in the fourth quadrant. Now observe the main diagram. For the body, completely support is towards the left side. Left side is nothing but it may be in the second quadrant or it may be in the third quadrant. Now from all these things, you take the combination of support and the friction. Now the point is, why you are taking this combination? Means you will get the reaction force from the elimination of the support only. And this wedge friction is a application of the friction. So you need to take the combination of support and the friction. So our support is in the third quadrant. So we know the exact quadrant of the support from this procedure. Now observe the diagram, main diagram. So support is in the third quadrant, and by eliminating that support you will get one reaction force. So that support is acting on the body in this direction. In this direction means arrow mark will be towards the positive x direction only. So here draw one arrow mark towards the positive x direction from this third support quadrant. So you will get the reaction force in the friction quadrant in the fourth quadrant. So you will get the reaction force in the fourth quadrant from this procedure. So here draw one line, draw one reaction force which is projecting towards the fourth quadrant with some angle of the friction to the perpendicular of the surface of the contact. So this is the procedure for R1. Once again, observe the motion of the body. When P is acting on the wedge, body is moving in the upward direction. So motion is in the first quadrant and second quadrant. Friction and motion always opposes to each other. So friction is in the downward direction. So it is in the third quadrant and it is in the fourth quadrant. Now observe the main diagram and see the support quadrants. It is completely towards the left side. Left side is nothing but it may be in the second or it may be in the fourth. It may be in the third. Now we should get the reaction force from the support only, and it is belonging to the friction topic. You need to take the combination of support and the friction. So keep a tick mark for that one. From this support, that support is acting on the body in this direction. So in this direction, in the friction quadrant, you will get the R1 reaction force. So this R1 is coming from the support quadrant and friction. So you will get the R1 in the fourth quadrant with some angle of the friction. Next, here one more support is there for the body. That is nothing but you will get the reaction force R2. For R2 there is no extra procedure. From visually we can say that wedge is acting on the body in this direction. In this direction means it is projecting towards the second quadrant. So towards the second quadrant, you will get the reaction force R2 with some angle of the friction to the perpendicular of the surface of the contact. And remaining angle to the vertical direction y-axis is nothing but alpha. That alpha is coming from this angle of the inclination of the wedge only. So once again, there will be some extra procedure for the R1 only. There is no extra procedure for the R2. Directly from visually only we can say that wedge is acting on the body and it is projecting towards the second quadrant. So there is no extra procedure for the R2. So this is the free body diagram for the body. Now we will see the free body diagram for the wedge. Once again draw the wedge diagram like this, and here how many forces directly acting on the wedge? Here only one force is there, P force. So write P directly, which is projecting towards the negative x-axis. Next, for the wedge, here one surface of the contact is there, here one more surface of the contact is there, as here two supports are there. So here for this surface of the contact, draw one perpendicular. For this surface of the contact, draw one more perpendicular. So before getting into the reaction forces, first of all we need to draw the perpendiculars for the surface of the contacts. Next, here also again for R3 separate procedure will be there. As observe the main diagram, here you will get the R3 support, R3 reaction force. Here support is completely towards the downwards of the downwards of the wedge. So we cannot say whether it is in the third quadrant or it is in the fourth quadrant. So to know the exact quadrant of the support, again we need to opt one separate procedure. So for R3 separate procedure is there, and for R2 there is no extra procedure. Like by visually we can say that body is acting on the wedge and it is going into the fourth quadrant directly. So here you will get the R2 which is projecting towards the fourth quadrant with some angle of the friction to the perpendicular of the surface of the contact. Now we will see the R3 procedure. Now for R3 again draw one small x-axis, one more small y-axis. Now as we are getting the R3 from the wedge, see the motion of the wedge. Observe the main diagram. Here P is the external force which is applied directly on the wedge. When P is applied, wedge is moving in this direction. In this direction means towards the left side. Left side means it may come in the second quadrant or it may be in the third quadrant. So motion is in these two quadrants. We know that friction and motion always opposes to each other. So according to these two motion quadrants, you will get the friction in the first quadrant and fourth quadrant. Now see the support quadrants from the main diagram. Support is in the completely downwards. So down direction means it may be in the third quadrant or it may be in the fourth quadrant. Now what quadrant we need to select for the combination? We need to select the combination of support and friction. So keep a tick mark for this one. Now from this we got the support quadrant exactly from this procedure. Support is in the fourth quadrant. Now observe the main diagram. From the fourth quadrant, support is acting on the wedge in this direction. In this direction means in the above direction. So in the above direction, from this combination quadrant, you will get the reaction in the first quadrant in the friction. So you will get R3 in the first quadrant. So project one reaction force which is directing towards the first quadrant with some angle of the friction to the perpendicular of the surface of the contact. Once again, for the wedge you are getting two reaction forces. For R2 there is no extra procedure. For R3 separate procedure is there. For that procedure, see the motion of the wedge. So motion of the wedge is towards the left side. Left side means in these two quadrants. In these two quadrants. Next, motion and friction always opposes to each other. So you will get the friction in these two quadrants. Now see the support. Support is in the downward direction. So in the third quadrant and in the fourth quadrant. Select the quadrant which is a combination of support and the friction. From this procedure, you have done the quadrant for the support. So support is in the fourth quadrant. So support is acting on the wedge in the upward direction. So in the upward direction you will get the reaction force from this quadrant. So you are getting the R3 in the first quadrant. So these are the free body diagrams for the wedge for this type of the problem. Remember one more thing, for R1 and R3, for R1 and R3 separate extra procedures are there. So to get that extra procedures, we need to see the motion of that body and for the wedge. When you are drawing the free body diagram for the body, see the motion for the body only for R1 procedure. When you are drawing the free body diagram for the wedge, see the motion of the wedge in the R3 procedure. So this is the procedure to draw the free body diagrams for the body and for the wedge. Now we will see one more type of the problem. Here this is the problem. Here also for the body two supports are there. Same procedure. for the same procedure which is similar in this way only. In this way only I will explain only the R1 and R3 procedures for the body and for the wedge. So here for the body, here again two supports are there. So consider it as R1 and R2. For the wedge, two supports are there. Consider them as R2 and R3. For R2, there will be no extra procedures. For R1 and R3, separate extra procedure will be there. Now we will see that extra procedures. In the free body diagram for the body and for the wedge, first of all, we need to draw the perpendiculars to the surface of the contact. To that surface of the contacts only, you will get the reaction forces with some angle of the frictions. So here, in the free body diagram of the body, wedge acting on the body in this direction. So towards the fourth quadrant, you will get R2. Next, in the free body diagram of the wedge, body acting on the wedge in this direction. In this direction means which is projecting towards the second quadrant. So in the second quadrant, you will get the R2. For R2, directly from the main diagram, we can draw the R2 reaction force quadrants. Now for R1 and R3, we will see the extra procedures. Now we are seeing the R1 procedure. R1 is coming from the body free body diagram. So here draw one x-axis and one y-axis. Now R1 is the reaction force which is coming from the body. So we should see the motion of the body from the main diagram. Now here when P is the external force which is applied on this wedge and body and wedge are in the connecting positions, when this force is applied in this direction, body will tend to move in this direction. In this direction means towards the right side of the complete diagram. So right side means it may be in the first quadrant or it may be in the fourth quadrant. Friction and motion always opposes to each other. So according to these quadrants, you will get the friction in the second quadrant and in the third quadrant. Now observe the support for the body. Here support is completely in the downward direction. So support is in the third quadrant and it is in the fourth quadrant also. Now we need to take the combination of support and the friction. Now we know that from this procedure support is in the third quadrant. So from the third quadrant, support is acting on the body in the upward direction. So in the upward direction, you will get the reaction force. So R1 is coming in the second quadrant. So R1 is projecting towards the second quadrant with some angle of the friction. Next, R3 is coming from the wedge free body diagram. So see the wedge motion. When directly P is acting on the wedge will move in the downward direction. Downward direction is nothing but motion is in the third quadrant or it may be in the fourth quadrant also. Next, motion are in the third and the fourth quadrant. Then friction you will get in the second quadrant and in the first quadrant. Now see the support for the wedge. Support is completely towards the left side. Left side is nothing but it may come in the second quadrant or it may come in the third quadrant. Now you need to select the combination of support and the friction. So support is in the second quadrant from this procedure. You are getting from this procedure. So support from the second quadrant is acting on the wedge in this direction. In this direction means which is projecting towards the positive x direction. So from this support you will get the reaction force in the first quadrant. So R3 is projecting towards the first quadrant with some angle of the friction to the perpendicular of the surface of the contact. Once again, to draw the free body diagrams in the friction topic, you need to remember one thing. That is, you need to draw the perpendicular lines to the surface of the contact planes. For that perpendiculars, you will get the reaction forces with some angle of the friction. Why? Because here for the friction is related to the rough surfaces bodies only. So wherever you get the friction topic, you will get some angle of the friction. So you will get the reaction forces with some angle of the friction to the perpendicular of the surface of the planes. And here for the R2, there is no extra procedure. Directly you will get the quadrant. But for R1 and R3, you will get some confusion. Exactly in which quadrant support is there. So for that confusion purpose only, to get the clarity, we will opt on some extra procedure. In that procedure you can know the quadrant support exact support quadrant. So from that quadrant you can find the reaction force in which quadrant it is acting. So from that extra procedures for R1 and R3 you can calculate the reaction forces. And one more thing, when you are doing that extra procedures for R1 and R3, as R1 is coming from the body, see the motion of that body only. R3 is coming from the wedge, so see the motion of the wedge only. For which reaction force you are calculating that extra procedure, see that body free body diagram motion only. These are the procedures to draw the free body diagrams. Once again see the diagrams. This is the first problem and this is the second problem. You may get different types of the problems. Wedge may be in the inclined position also, body may be in the inclined position. In any combination, in any diagram, this is the procedure. You need to see how many supports are there. From that supports, how many exact quadrants are there. From that exact quadrants and from that supports, how many reaction forces you are getting. For any problem, this is the only procedure. So from this procedure you will draw the free body diagrams. After drawing the free body diagrams, you can draw the rectangular components force diagram. From that rectangular components force diagram, you can calculate the reaction forces and that external force which is acting on that combination of the body and the wedge.